Hello everyone, welcome to Geeks for Geeks. Today we are going to solve the question count smaller elements. So first we will see some sample test cases, then we will find the approach of that question, then we will code that question. Okay, so let's start the question. Okay, so basically the question statement is given an array containing non-negative integers, count and return an array answer. Okay, where answer I denotes the number of smaller elements on the right side of array. Okay, so this is basically the problem statement over here. So basically they have given us a array, this array. We have to create one more array, that is answer array. Okay, we have to create a same array that is of the length of same this length. Okay, we have to create array of answer. Now what we have to calculate is, like, this is 12. Okay, so we have to put the answer of ai matlab, answer of a answer of 0 over here. What is going to be that? The answer is going to be the number of elements which are smaller than 12. Okay, so how many numbers are smaller than 12 from there? Right. Okay, so basically 1 2 3 4 5 and 6, all the 6 numbers are smaller, so I will put 6 over here. Now it is a 1. Okay, now we are at 1. Okay, how many elements which are smaller to their right side? Okay, so basically only 0 is smaller, only one element is smaller than 1, so I will put a 1. So for the 2 part, how many small elements are smaller to the right side of this part? Okay, only 0 is smaller than 2, so I will put a 1. Okay, 3, how many elements are smaller to the right side? Okay, so only one element is smaller. For 0 part, no elements is smaller, so I will put a 0 over here. For 11, we have just one element that is small. For 4, we have no elements, that is 0. Okay, let's try it with this example as well. So I will make an answer array, and now for 1, we have 0 elements on the right side which are less than 1. Okay, 0. For 2, we have on the right side we have 0 elements which are greater than, which are smaller than 2, 0. So for similarly for the 3, we have on the right side we have 0 elements which are greater than, which are less than 3. Okay, for 4 similarly we have 0, and for the 5 we have 0 as well. Okay, so this is the sample test cases. Okay, let's try it with one more case as well. Okay, 9 6 3 1 0 4 2 and 7. Okay, let's see this example as well. Okay, so firstly there is 9. Okay, so how many elements are which are smaller than 9 is, so 6 is smaller. Okay, so every element is smaller, 1 2 3 4 5 6 and 7. So I will write 7 for this. 6, so how many elements that are smaller to the right side of this part? So 1 2 3 4 5, so 5 elements are smaller than 6. 3, for 3 part, for 3 this one is smaller, 1 2 and 3. For 3, there are 3 elements which are smaller than 3. For 1, only one element. For 0, 0 elements will be small. For 4, only one element will be smaller. For 2, there will be 0 elements. For 7, will be 0 elements. So basically, after doing these types, this sample test case, after solving, you might get an approach in your mind of n square approach. Okay. So what we have to do for this part is, let's solve it one more time. That is going to be something like that. Firstly, I will firstly make a array, and then I will go on this element and will search for this part. Okay, will search for this part. Okay, I will go for the 9 and I will make one count element, count pointer, and I will initialize firstly it with 0. Then 6 is smaller than I, then I will increase this count 1. Now 3 is also smaller, so I will increase it by 2. 1 is also smaller, I will increase it to 3. 0 is also smaller, so I will increase it to 4. Similarly, I will go something like this, and I will put the answer. Okay, how many, what is going to be the answer? 1 2 3 4 5 6 and 7. Okay, when I go for the next element, I will initialize one more time. I will initialize this count with 0, and then we'll calculate and we'll start a new loop from this point and calculate the small elements which are less than 6. Okay, so what elements are less than 6? 1 2 1 2 3 4 5. So 5 element I will write. So this approach is going to be approach of n square. N square, this approach, the time complexity of this approach is going to be n square, the time complexity, but the space complexity of this approach is going to be O of 1, because we are not using any space. Okay, that's why this is going to be, the time complexity is n square. So but they have given in the question, they have given that please do this question by n log n, and you can use space O of n. Okay, now there is a log n. Okay, so there is a log n, and from log n I'm getting some approach from this part, that if I just use some kind of sorted type, if I can use sorted array type of thing, then I can put a log n type thing, then I can put a log n type thing. Okay, so what is going to be the approach of this question? Okay, let's take one more example. Let's take the example of this example. Let's take this example only. Okay, so what is going to be the efficient approach over here? Let's take this example. So the array is 12, 1, 2, 3, 0, 11 and 4. So the array, this is the array. Okay. So now what is going to be the array? Now you can see over here, let's also see the answer as well. Okay. So for this part 0, 1, 0, 3 and so, oh sorry. So what is going to be the answer? It is going to be 6, 1, triple 1, 6, triple 1, 0, 1 and 0. Okay. So this is going to be the answer. Okay. So we have already discussed how this answer has come. So now you can see over here for the last element, every time the answer will be 0 because there is no element even in the right side. That's why always this will come as 0. Okay. So now I'm getting some approach kind of thing. So I will store this 4 in an array list. Okay. In an array list, I will store this array, and in the answer, I will start filling my answer array. This is my answer array. This is going to be my answer array. And this is going to be my list. Basically this is going to be a list. Okay, this is going to be a array list. Okay, this is going to be a array list, and this is going to be a answer array. Okay, now firstly I will put that 4 in the array list, and I will put the 0 at the last index. Okay, now what is going to happen over here? I will push this 11 on. Now the 11 element will be 11 would come. Now the 11 element would come over here. Now what is going to happen over here? If I just find that what is going to be the index if 11 is present in this array list in a sorted order, because we are going to implement binary search over here. Okay, so I will tell you how to implement that also. Okay, binary search. Okay, now what is going to be the position if this 11 would be over in this array? What is going to be the position of this 11? Okay, so the 11 going, the position of 11 is going to be, so 4 is present something like this, and if the 11 is present over here, then 11 will be here. Okay, so now if I just find the index of this 11, so if it is present, okay, it is not present now, but if it is present, then what is going to be the index? So the index is going to be 1, and now you can see over here that the element which are less than 11 is also 1. So firstly I will put 1. Okay, I will tell you the reason, okay, why I am putting. And also what I will do, I will push the 11 in the array list as well. Okay, now we are here at 0. So now just imagine what is going to be the position if 0 is present in this array. Okay, so if 0 is present in this array, then that would come at the 0th position. And also you can see over here that 0, only 0 elements are greater than 0. Okay, so I will put the 0 over here, and also I will push this 0 at the 0th index. Okay, now there is 3. So what is going to be the, what is going to be the index of 3 if 3 is present in this array? What is going to be that? Okay, let's assume, so the array is going to be 3. Now you can see over here that 3 is also 3, the index is going to be 1, and also the elements which are less than 3 are also 1 because 0 is the answer. So now you can see over here, I think you are getting this approach. Now that would be 2. Okay, let's make this array one more time. So this is 0, 3, 4 and 11. 0, 3, 4 and 11. Okay, now this is going to be 2. Okay, what is going to be the position of 2 if 2 is present in this array list? So it would be this position. And what is the index of this position? Is 1. Okay, what is going to be the index of this position? That is going to 1. So now you can see over here only one element is less than this part. Okay, so now I will put this 1 over here as well. Okay, now we have this, I think 2, I think we have using this 2 over here. So this is going to be the 2. Now we have this one element. Okay, now what is going to be the position of 1? Let me write this array one more time. Okay, so 0, 2, 3, 4 and 11 is going to be this. Okay, now what is going to be 1? Okay, so now if the 1 would be present over here, then 1 would present as the 1 index. Okay, now you can see only 0 is lesser than this part. Okay, so that's why I'm putting 1 over here. So 1, 2, 3, 4, 11. Now what is going to be the position of 12 if 12 is present in this array list? So what is going to be the position? 12 is going to be present over here. What is the index of this? 0, 1, 2, 3, 4, 5, 6. Okay, so this is going to be the 6th index. And now you can see over here that the answer we have predicted and the original answer is same. Okay, because we are finding this using binary search. Okay, we will find the potential index of the array using binary search. That's why this is going to be the approach of n into log n into the log n. This is going to be happen over here. So let's try it with one more example. Okay, let's try it with one more example. Let's say 4, 3, 1, 9, 2 and 0. Okay, let's take. So firstly, what we are going to do, firstly we will make an answer array like this. So answer array, and we are going to put the first index as 0, last index as 0, and also we will make a array list, we will make a array list and push the last element of that into 0. Okay, now we are at this position and we want to fill this answer position of this answer array. Now 2, what is going to be the index of 2 if it's present? So if it is present, then it would present at this index, and this index is 1. Okay, and now you can see that only one element is lesser than this. Okay, so I will put a 1 and I will add, after this I will add 2 to this array. Okay, okay, let's not put this thing. Okay, 0 and then I will push 2. Okay, now we are at 9. So what is going to be the 9 position of 9 if it is present in this array list? So it would be this position. This means this, the index of this 9 is 2. So I will put a 2, and you can see over here that only 2 elements are smaller than 9. So I will put the 9 as well. After putting this index, I will put the 9 as well. Oh, 1. So what is going to be the index of 1? So 1 would present be here. Okay, what is the index of 1? That is 1. Okay, so I will put a 1. Now you can see over here only one element is less than this. 0 elements are less, 2 element 1. For 9 there are 2 elements which are less than. So currently the answer is being correct. Now this 3 would come over here. 3 would come over here. What is the index? 0, 1, 2, 3. So that would be 3. Only 3 elements are less than this part. Okay, for the 3 part, for the 4 part, what is going to be the position of 4? Position of 4 is going to be this. Okay, 0, 1, 2, 3, 4. So only the 4 elements, 1, 2, 3 and 4. So now you can see that we have got the right answer over here. So let's understand the code as well. Okay, so what I have done in the code, you can see over here, firstly I have made a array, answer array in test 9, and putting the last element. So last element as 0. Okay, now I have made one array list. Okay, in the array list I have added the last element as well. Okay, now I have started the loop from the n minus 2 index. Okay, basically it is the second last index, and I'm going till 0. Okay, so now I would find the get index. I have written a function that get index. Okay, so we will see how this get index is working. Okay, now I have put in the answer I as index, because on the index we are getting that number which is going to be the answer, and I'm also adding this as in this list. Okay, then I'm returning this answer. Okay, now let's understand how the get index is working. Basically in the get index I have do nothing. It is a recursive function which is using binary search. Okay, in this part you can see we have sent the array list, the key part, which element we want to find the index, and the start and end point. If the start is less than equals to end, then what we have to do? If this is the condition, then we have to find the mid of this part. So I find the mid. If key is less than equals to list dot get mid, so we have to put end minus 1. Basically the basic binary search, we have put in the basic binary search over here, and we are returning start from here. So this is how we are doing this question. Okay, let's try to run it. Okay, let's try to submit it as well. Okay, so the question is submitted. I hope you have all have understood this question very well. Thank you.